All right, let's finish up our notes on transformations on functions of graphs. So far, we have not talked about what happens when we take the absolute value of f of x or when we take the absolute value of x in a function. So these were the last two that I was going to talk about. Now, what does it mean to take the absolute value of a number? Well, that means that I'm always going to have a positive number, right? Because when we defined absolute value, it was always the distance from 0. So that's a positive number. If I put the absolute value signs around the output, around f of x, then I know that all outputs are going to be positive. So that means I have to reflect in x-axis any negative outputs. And then if I do the absolute value of the input, then that means that all inputs become positive. So reflect in the y-axis all outputs of just positive x values. What am I talking about? Well, let's go ahead and let's do a few of these problems. So we're going to go down, let's see, to this final one here. Absolute value transformations. This is from 1.6. And I've given you what your book says. And I've also taken that little bit of our table from the front page and I've placed it right here. So I'm going to go off of this and try and make sense out of this for you. All right, so we did examples of reflections and absolute value transformations. And I'm going to right now just focus on these absolute value transformations. So let's start with taking the absolute value of f of x. So I'm going to take this one here. And that means that all my outputs have to be positive. All outputs are going to be positive. So if I have any negative outputs, those need to be reflected in the x-axis. All right, let's practice that. So we're going to do that with C here. And I'm going to go down because maybe we'll do A and B in a minute. But let's go ahead and let's do C here. All right, so I'm going to take this graph that's f of x, and I'm going to create a of x. I'm going to use my red pen for that so that it kind of differentiates. Now, again, back to this, it says that all outputs have to be positive. All my f of x's have to be positive. So any x values, or sorry, any y values that are negative will be reflected in the x-axis. So let's look for a few of these. Well, starting from the very left, I can see that my endpoint, which is at -9, -4, that is definitely a negative output. So what's going to happen is at -9, my output needs to become +4. Let's see. Everything that was positive is going to stay positive, or anything that had an output of 0 also stays there. So this whole section here is going to stay just like that. I've got a negative critical point. So let's see, -2, -5 is a critical point. So -2 should not have an output of -5 anymore if I'm going to take the absolute value of all of those outputs, right? What should the output be at -2? Well, let's go ahead. I'm going to prove this one to you. How about that? So we'll do just a little input-output table. I'll just do this one time to prove to you what I'm talking about. And I'm going to do an absolute value of f of x. All right, so I plug in -2. So that's f of -2. Well, what was f of -2? F of -2 originally was -5. So now it's the absolute value of -5. And what does that become? That becomes +5. So basically, I'm going to take this critical point that's at -2, -5, and I'm going to reflect it in the x-axis so that -2, +5 becomes that point. All right, my y-intercept. I've got a y-intercept there at 0, -2. So that point, when I take the absolute value of that output, becomes a positive. So 0, +2. All right, let me go ahead and graph that section. So that's just the left side. Just going to follow that graph, right? And that's going to follow that pattern so it's reflecting in the y-axis, or sorry, in the x-axis, not the y-axis, the x-axis. All right, now let's go ahead and let's do the right-hand side. So anything that was negative, any of those negative outputs are now reflected. Any of my zeros stay exactly where they are. Anything that was positive output stays exactly as it was. So this part stays like it was, and this part will come down. It's just a reflection of that negative piece of the graph. That should be a straight line. So let me try that one more time. It's challenging. There we go. All right, and then the last part, I'll take that critical point at 6, -5. And where do we think that belongs? Well, that critical point 6, -5 belongs at 6, +5. And I'll take my far right endpoint of 7, -4. No negative outputs. So at 7, my output now becomes +4. And I'm going to reflect basically that last piece of the graph in the x-axis. So it should look parabolic of some sort. All right, so that's when we take the absolute value of the entire function. Let me use a different color. How about green? This is where we're going to now do the absolute value of just the input. So that means all of your inputs become positive. So what you're going to do is reflect in the y-axis all outputs of the positive x values, because now you don't have any negative x values anymore. They all become positive. All right, so what does that mean? That means that this piece of the function right here, all of this stuff over here on the right-hand side of the graph, those are all outputs of positive x values. And so that piece of the graph is going to need to get reflected in the y-axis. You're no longer going to have all this other piece. This piece here that I'm tracing right now doesn't exist anymore. Okay, instead it's going to look like basically all the outputs that the positive x values produce. Now, why does this happen? Maybe I can show you this with an example. Let's look at x equals -2. The output for x equals -2 is -5. It's right here. Well, let's see what happens when I actually perform the absolute value of the input on this. Okay, so I'm going to make a table again. I'm going to have x. I'm going to have what happens when I do the absolute value of x. And then I'm going to have what happens when I do f of the absolute value of x. All right, so for this example, the point that I want to choose is -2. The absolute value of -2 is +2. So this actually becomes f of 2. Well, what was f of 2? F of 2 was actually 1. So that means that f of -2, when I plug in -2, I'm actually going to get out a +1. Notice that that's a reflection in the y-axis. Okay, I'll do it a couple more times. Let's do -6. Well, take the absolute value of -6 and you're going to get 6. So what's f of 6? Well, let's see. F of 6 over here was, it looks like -5. So that means that that output at +6, which was -5, needs to also be your output at -6. Okay, can I reflect? Let's see, will 0 change if I put in an input of 0? Nope, that's going to stay exactly the same. Right, so I can see that this function is basically going up and down. It might be helpful if I know that I have a 0 at -1. And I'm also going to have a 0. I'm just looking at the right-hand side at all those positive x values. I have a 0 also at +3. So that means at -3, that's reflected in the y-axis. It's going to come down like this. Okay, then what's going to happen? Let's see. So on the right-hand side, my endpoint is at 7, -4. So then that endpoint is now going to go -7, -4. So it should be here. So that should be the end of my graph. Well, that's interesting because on your original graph, you also had -9, -4. You got that point. Let's talk about what happens with that point. So if I plug in -9, the absolute value of -9 is going to be +9. So then I would need to find f of 9. Where is f of 9? Let's see, 6, 7, 8, 9. It's here. Is there any f of 9 anywhere? There is no f of 9. That is undefined on the original function. So it does not exist on f absolute value of x. Okay, so this one's does not exist. It's not in the domain. And that was D. I didn't label that. So that was that one here. Let's do A and B real quick, because I think we can do it quickly. Let's do A in blue. Or at least I'll do A in blue. All right, so if I do the opposite of the function, well, that's an outside transformation, and that's going to be a reflection in the x-axis. So this right here is reflect in x. So I'm going to take every single output, right, and I'm going to negate it. I'm going to do the opposite of it. All right, so let's find some outputs here. So I'll start from the very far left. I'll do like endpoints and critical points. Okay, so my endpoint of -9, -4 now becomes -9, +4. My zeros stay the same because doing the negative of a 0 is still just 0. My critical point at -6, 1 now becomes -6, -1. My critical point at -2, -5 now becomes -2, +5, right? Just doing the opposite of that output. Let's see, I have a y-intercept at 0, -2, so that's going to become 0, +2, doing the opposite of that. Your zeros again, doing the opposite of a 0, still just 0, so I'll keep those. But I have a critical point at 2, 1, so that now becomes 2, -1. And I have a critical point at 6, -5, so that now becomes 6, +5. And I have an end point at 7, -4, so that now becomes 7, +4. So your graph now should look something like this. And that's just a really nice review for you. All right, let's do another one. Let's see, let me choose a color here. How about purple? All right, let's do B. B's not that much of a review for you. We are now doing the opposite of the input, which means that for every input, whatever that output was, it's going to go to the opposite x value. All right, so basically what this is it's going to be a reflection in the y-axis, right? So this is a reflect in the y-axis. All right, so I'm going to take, for example, at -9, I had an output of 4. Okay, so I'm now going to make that a +9, -4. Again, I'll do endpoints, I'll do zeros, and I'll do critical points. So at -7, I had a 0, so that now becomes +7, 0. At -6, I had a critical point of 1, so now +6 has a critical point of 1. At -5, I had a 0, so now at +5, I have a 0. Critical point at -2, -5, so now I have a critical point at +2, -5. Y-intercept isn't going to change at all, right? Because you can't reflect that on the y-axis. All right, and now on the right-hand side of the y-axis, I'm going to reflect those points. So I have a 0 at 1, 0, so that becomes a 0 at -1, 0. I have a critical point at 2, 1. That now becomes a critical point at -2, 1. I have a 0 at 3, 0. That's now -3, 0. I had a critical point at 6, -5. So now we'll do -6, -5. And the endpoint, the last endpoint on the right-hand side was at 7, -4. So now it's going to be at -7, -4. And there you have it. All right, even and odd functions. You guys are familiar with even and odd functions. There are a couple of things I'm going to have you test out here. So first of all, look at the even function on the left side. So here's an even function. Okay, what the even function is saying, and yes, they're basically going to have even powers in an even function. An even function has symmetry in the y-axis. And you can test to make sure that something is an even function if you do the negative of the input and still get the exact same output. Okay, and so what this tells us is that we end up with symmetry in the y-axis. All right, so what do I mean by that? Let's see, let's go over here. So let's take this f of x, which is -x to the 4th plus 5x squared minus 1. And I'm going to test out this rule for even functions, this rule right here. So let's plug in, let's make our a, so you can see like you have a's here. Let's make a equal 2. So the question is if I plug in -2, will I get the same as if I just plug in 2? This is missing a little parenthesis there. Well, we're going to have to test it out, right? So let's try it. So will f of -2 equal f of 2? That's our question. If it does, then we know for a fact that this is an even function. All right, so I'm just going to go ahead and plug in -2, and then I'm going to plug in 2. All right, so f of -2, well, that's going to be, let's see, I'm going to probably run out of room. Let's try it. Negative, and then I got a -2 to the 4th power, which obviously anything negative raised to the 4th power is just going to be positive, plus 5, and then I'm going to plug in -2 and square that, again, becoming positive, minus 1. So I end up with -16, because -2 to the 4th was positive 16, and then there's a negative in front of it. -2 squared is positive 4 times 5, that's 20, minus 1. So it looks like I'm going to end up with 3 here. All right, so let's see if f of 2 gives us the exact same output. Let's do it down here. So negative, and then I'm doing 2 to the 4th power, and 5 times 2 squared minus 1. Notice all those powers, right, are still going to become positive, right? 2 to the 4th is positive 16, and then do the opposite of it, so negative 16. And then we have 2 squared, which is 4, times 5 is 20, minus 1. So I'm getting the exact same thing, right? So in fact, this is an even function, okay? And visually, we know it's an even function because there's symmetry in the y-axis. Now let's look at odd functions. So odd functions, and you can see this graph down here is an odd function on the right-hand side. Odd functions have symmetry, not in an axis, but in an origin. I think it's IGIN. And if you remember, we had done something like this in geometry, okay? Whereas the rule was if we plug in a negative input, that makes the entire function negative for its output. Okay, so let's test that one. So that's the rule. We're going to use this odd function, and I think I'll use the exact same a. Let's try a equals 2. So our question is, if I plug in 2, is f of -2 going to equal negative f of 2? Let's try it. So I'll start with f of -2 is that going to equal negative f of 2? That's our question. That's what we have to figure out, and that's how you would prove that two functions or that a function is odd function. Okay, so let's plug in. Let's start with f of negative 2. I'm going to get negative. Then I'm going to plug in a negative 2 cubed plus 6 times negative 2. All right, we'll keep that negative out there, but then this negative 2 cubed is negative 8. So that's just going to give me a positive 8 minus 12. Looks like I'm getting negative 4. Now let's try doing the opposite, f of 2. All right, let's try that. So now I'm going to have my entire function be negative. So whatever happens, we're going to do the opposite of it. So I'm going to plug in negative, and then I've got 2, or sorry, I'm not plugging in negative. That's part of the function. I am plugging in 2. I'm cubing that, plus 6 times 2. Leave that negative outside. This first term becomes 8, right? 2 cubed is 8, and then there's a negative there. So it's negative 8 plus 12. Okay, so that ends up being, in the parentheses, just 4, but I got a negative outside. Oh my gosh, look at that. And that is how you can test whether a function, if you're just given the equation, you can test whether or not the function is even or odd by actually following these two little tests. Otherwise, if you're given the graphs, you can look for symmetry in the y-axis and know that it's an even function, or you can look for symmetry in the origin and know that it's an odd function.